A strong acid versus a strong base. Here we have taken 20 milliliters of a 0.5 molar hydrochloric acid solution and a 0.5 molar sodium hydroxide solution for the titration of a strong acid with a strong base. Let's explore this titration. Fill the burette by clicking on the beaker with the sodium hydroxide solution. Click on the funnel to remove it from the burette. Select the indicator bottle to add a few drops of phenolphthalein indicator in the conical flask filled with the hydrochloric acid solution. Observe the graph. Initially, the concentration of hydrogen ions in the hydrochloric acid solution is high, so the pH value of the hydrochloric acid solution is very low. Click on the highlighted stopcock to add the sodium hydroxide solution dropwise into the hydrochloric acid solution. Observe the graph carefully. As NaOH is added, you can find that the pH of the solution increases slowly. Click on the highlighted stopcock to add more sodium hydroxide solution dropwise into the hydrochloric acid solution. At a certain volume, the number of hydronium and hydroxide ions becomes equal. This stage is called the equivalence point. The equivalence point is achieved just before the endpoint. Click on the highlighted stopcock to add more sodium hydroxide solution dropwise into the hydrochloric acid solution. After achieving the equivalence point, if we continue to add the sodium hydroxide solution to the hydrochloric acid solution, the color of the solution changes to pink. This stage is called the endpoint. Once the endpoint is achieved, the concentration of hydroxide ions increases, and at a certain point it becomes maximized. Thus, the pH of the solution increases. You have completed this activity. Select OK to return to the menu and continue to the next activity. Assess your knowledge. Follow the instructions to perform the assessment and earn points. You can try multiple times, but points are only awarded if you answer correctly on the first try. Click on the graph obtained from the titration of a strong acid with a strong base. Right! Observe this graph carefully and answer the questions. The volume of the base consumed by the acid to achieve the equivalence point is milliliters. Correct. What is the ratio of the concentrations of hydroxide ions and the hydronium ions at the equivalence point? Right! Which point denotes the endpoint of the titration of a strong acid with a strong base? Correct. You have completed the assessment. Here is your score.